Hi everyone, I am Ankit Mishra and I have been guiding GATE Chemical Engineering aspirants for past 4 years. I am excited to bring you a comprehensive PYQ series covering all subjects designed to strengthen your conceptual understanding. So here you can see each video is organized topic wise, allowing you to focus on weak areas and master them efficiently. So this don't miss out. Subscribe to my channel and share it with your friends to maximize your GATE preparation. So without wasting our time, let's just start with the new topic of PYQ series, that is fluid dynamics. This is very important topic. Every year get used to ask a question from this particular topic, which is based on the momentum balance equation, right? So earlier we have discussed about the mass balance equation that was based on the continuity equation, that is also called the continuity equation. And in Navier-Stokes equation, second part is momentum balance equation that we are going to study in this lecture. So this is very important lecture. This year also you are going to get one question from this particular topic. So first question says that a free jet of water of cross-sectional area 0.01 meter square and the velocity is 20 meter per second strikes a plate and then flows in the plane parallel to the plate as shown in the figure below. The horizontal component of the force on the support is. So here in this particular problem you can see a free jet is coming along this direction and it is going to strike on the jet, and you can see this jet is going to collide with this plate, and after that this is start moving along this direction, along the horizontal direction, I mean vertical direction of the plate, right? So the horizontal component of the force you are supposed to calculate. So what will be the horizontal component of the force that is being applied on the support? So you are supposed to calculate the force along this direction, not vertical direction, right? So if I am calculating this force, so if I'll apply the Newton's second law of motion, that tells us that force is equals to rate of change of momentum d upon dt of p. So I can write d upon dt of mb. So what can be written? M dot v, right? Mass flow rate multiplied with velocity, right? So if velocity is constant, velocity is not going to vary, right? So what is mass flow rate? So mass flow rate can be written as rho into area into velocity. So force can be written as rho into area into velocity multiplied with velocity, that is rho a v square. That is simple. And now you can see that density, water is there, so density will be 1000. So I can write 1000 multiplied with area of the jet is also given 0.01 meter square, and what is the velocity of that is 20 square. So now you can calculate these things. 1000 into 0.01 multiplied with 400, so that will be equals to 4000 Newton. So from here you can see your option 4000 Newton. So option D will be your correct answer. This is very simple and fundamental question, but you just need to understand the the statement that is being given in the problem, and once you read these things carefully you will get an idea, okay, what sorts of thing that is being applied here. So concept was applying the Newton's second law of motion and force balance, that is. So if you apply the Newton's second law of motion, rate of change of momentum is called applied force. And how can we calculate the momentum, rate of change of momentum? So mass flow rate is given to you, and you can calculate mass flow rate, that is rho into a into v. That is very important equations in case of fluid mechanics, right? When we talk about the fluid dynamics especially, right? Because fluid is in motion. Moving towards the next question, this is also very important question asked in GATE 2000 having 5 marks. So definitely you are going to learn lots of concepts from this particular topic question. You can see a free jet of water is produced using a 75 millimeter diameter nozzle. So here this nozzle is there and the diameter of this nozzle is 75 millimeter, that is given to you, and attached to a 200 millimeter diameter of the pipe. So here this nozzle is attached with the pipe having diameter is 200 millimeter as shown in the figure. If the average velocity of water at a plane B is 3.8 meter per second, so average velocity u bar is given, that is 3.8 meter per second at point B here, right? So average velocity at point B is given. Calculate the velocity of water at point A. So you are supposed to calculate what is the velocity of water at point A. VA is equals to what? Neglecting the frictional loss in the pipe. So you are not going to consider any frictional loss. So first what we have to understand here, that the velocity we can apply, obviously you can apply the Bernoulli's equation, because we are now studying about the fluid dynamics. So we can apply the Bernoulli's equation at point C. Let's say if I am assuming this one is point C and point A, at point A and point C definitely we are going to apply the Bernoulli's equation. But before that we can also apply the Bernoulli's equation at point B and point C, because the velocity at point C is not given to you, so you have to calculate the velocity at point C also. So how to calculate the velocity at point C? So if I apply the Bernoulli's equation at point B and C, so what I can write, PB by rho g plus VB square by 2g plus, let's say, ZB, that is equals to PC divided by rho g plus VC square by 2g plus ZC. Is that clear? Okay, great. So if I am assuming this one is the datum level, so what is the height? ZB is 0, then what is ZC? ZC will be equals to 0.5 minus 0.2. So that is how much? Because what is this height? This height will be your 0.1, I think. Yeah, 0.1 mm, right? So ZC is 0.1 mm, right? Sorry, 0.1 m. So let's try to see where is the point C. So C is here. So the height of C from point P is your 0.5 meter, right? So let's try to understand. But again, one thing you have to understand here is velocity at point B, right? So velocity at point B is given to you, right? And so basically what we can see, that directly we can calculate the velocity at point B C directly using the these things, continuity equation, right? Because the whole flow is going in along this direction, right? At point C, diameter at point C is given to you. So what I can say, right, area of cross section into velocity at point C, that is equals to area of cross section at B multiplied with velocity at point B. So area of cross section here, pi by 4 into 0.075 whole square multiplied with VC, that is equals to area at point here, this one is 0.2 whole square multiplied with pi by 4, and again what is velocity, that is 3.8. So pi by 4 will get cancelled out. So velocity at point C can be written as 0.2 divided by 0.075 whole square multiplied with 3.8. Is that clear? Okay, so once we do the calculation of these things, we will be getting velocity at point C, and that value is your 27 meter per second, right? So why I have used this thing? Because pressure was not given. So if pressure would be given, would have been given to you, then definitely you can use Bernoulli's equation. But it is fine that if continuity equation is giving you the velocity, that is a very simple thing, right? So this is called as the continuity equation in fluid dynamics, right? And this is also a part of Navier-Stokes equation. Now moving towards the next point, that apply Bernoulli's equation at point, applying at point C and A. So what I can say, that PC divided by rho z plus VC square by 2z plus ZC, that is equals to PA divided by rho z plus BB square by 2g plus ZA. Is that clear? Okay, so since both of these are in open atmosphere, so obviously PC by rho g and PA by rho g will be PATM by rho g, so it will get cancelled out, and we are supposed to calculate BA square by 2g or BA. So what is ZA minus ZC? So ZA minus ZC, obviously from the figure you can see 18.5 minus 0.5, that is equals to 18 meter. So what is yeah, and after that you can substitute these things, that 27 whole square divided by 2 multiplied with let's say 9.8 minus 18, that is equals to BA square divided by 2g. Is that clear? So let's try to calculate this value, how much value we are getting from here. That is very important. Once you do the calculation, 2 multiplied with 9.8 multiplied with obviously 27 square and minus 18 and multiplied with 2 multiplied with 9.8, and again we'll do the root over. So the value of velocity at point A will be 19.39 meter per second. So this value you will be getting from this particular calculation, 19.36 or 19.39 millimeter per second, something like that. This is very important question where you learn two concepts: how to apply the continuity equation and how to apply the Bernoulli's equation in order to calculate the velocity of free stream. Okay, moving towards the next question. This is also very important kind of question that you can say that is also based on the momentum balance equation. The question says that the inlet velocity of water here at point 1 here is 1 meter per second, and density of fluid is given to you 1000 kg per meter cube, obviously, and diameter here is given to you. Diameter is 0.8 meter and that outlet diameter here is 0.4 meter. The flow is turbulent, obviously it's very different question, and the velocity profile at the inlet and outlet profile is flat because turbulent flow, plug flow profile will be followed. The gravitational force are negligible. Find the pressure drop across the band assuming negligible friction loss, right? So if frictional loss is negligible, what is pressure drop across this? Okay, so in order to calculate the pressure drop, I can assume that I can apply the Bernoulli's equation at point 1 and point 2. So if I apply the Bernoulli's equation at point 1, that's I can write P1 by rho g plus V1 square divided by 2g plus Z1, that is equals to obviously P2 by rho g plus V2 square divided by 2g plus Z2. Okay, so V1 and V2 is given to you. V1 is given to you, and if V1 is given, you can calculate the V2, right? So how can we calculate the value of V2? So let's say Z1 and Z2 is same level at negligible. So I can calculate P1 minus P2 divided by rho g, that is equals to V2 square minus V1 square divided by 2g. Is that clear? So you can see that diameter at point 1 is 8 and diameter at point 2 is 0.4, right? So if I calculate that area into V1 equals to A2 into V2, so what is V2? V2 will be equals to A1 by A2 into V1. So A1 is how much? 0.8 square, right? So pi by 4 8 square and 0.4 square into 1. So that will be equals to 4. So velocity V2 will be equals to 4 meter per second. So if I calculate P1 minus P2 divided by rho g, so you can write 4 square minus 1 divided by 2 into z. Z and z will also get cancelled out. So P1 minus P2 will be equals to 15 by 2 into z, that is 10, let's say. So 5. So P1 minus P2 you will be getting 75 Pascal, right? So yeah, P1 minus P2 you are getting is 75. Sorry, rho is 1000. So I'm extremely sorry for that. So rho is 1000. So you have to substitute here 1000, right? So from here you will be getting the value that P1 minus P2 is equals to 7.5 into 1000 Pascal, that is equals to 7.5 kilopascal. P1 minus P2. Okay, great. After that, I'll be moving towards the next question. This question has been asked in GATE 2003, and this is really good question to understand how you can apply the mass balance in this particular kind of problem. So let's say a pipe has a porous section. So you have seen that you can see this pipe is there, and after that, okay, this pipe looks like that, having porous section. Okay, so this pipe is looking like that, something porous section, and after that you can see that at this point and here, velocity here is V naught and the diameter of this pipe is d, and some fluid is also entering due to this porous nature of the porous section of the pipe, and from here and from this direction, right? So this is, let's say, x is equals to 0, and this point is your x is equals to L. Okay, so if I'm going along this direction, this is our x-axis. So velocity at the inlet of the pipe here is v naught, and the fluid which is entering the flow rate here, that is given as qx is equals to q naught into obviously x square divided by L square, right? Q naught into x by L, sorry, q naught into x by L. Okay, so you are supposed to calculate that what is the velocity profile, right? Velocity profile in that particular direction, vx direction, right? So this can be calculated while using the mass balance equation. So if I am assuming, let's say this is the porous section, and obviously here, so I am assuming a thickness of dx element here, mass flow rate is going, so mass flow rate in, mass flow rate out, and here some mass flow rate is also coming from this direction, right? So what I can write, m dot in minus m dot out, that is equals to, at a steady state will be equals to 0. So what is mass flow rate in? At mass flow rate in, mass at x minus mass flow rate at x plus dx plus mass flow rate is happening along this direction, qx into pi d into obviously dx from this particular area, surface area, qx into pi d x. Okay, so mass flow rate in here at in is I can write minus dm dot divided by dx plus qx into pi d dx, that is equals to 0. So dx will again here it will be dx. So obviously, so I can write now dm dot divided by dx, that is equals to qx into pi d, right? And what is m dot? M dot can be written as rho into a into vx. Is that clear? So what is a? A is equals to pi by 4 into d square, or capital D square is given here. So we can substitute here is capital D square. So now we can substitute rho a into pi by 4 d square and dvx divided by dx, that is equals to qx is equals to q naught into x by L into pi into d. So d and d will get cancelled out pi and pi will also get cancelled out. So finally we are supposed to calculate the velocity profile. So dvx integral, that will be equals to q naught by 4 q naught by rho, and obviously area is getting removed now because we have substituted rho into d, and after that 1 upon L and x dx, and now 0 to L, right? So vx will be equals to 4 q naught divided by rho d into 1 by L into x square by 2, and obviously 0 to L. So vx will be going from v naught to vl or vx. Is that clear? So we are supposed to find out the velocity profile only, right? So once we'll substitute, let's say 0 to x. So what will I get? Vx, that is equals to v naught plus 2 I think I have written something wrong here. It has been given qx by L whole square, actually, sorry for that. So that is x square L square x cube by 3, right? So that will be x cube by 3 only, that's it. And here there will be L square, that's it. So vx is equals to v naught plus 4 by 3 q naught, and again by rho d into obviously x cube divided by L cube, something like that. So you can see from your action v naught plus 4 Q okay, so there will be a density along this side also, that rho. So rho and rho will get cancelled out from all of this side, right? So there will be rho, and now you can remove the rho value because rho will get cancelled out, that is d only, and from here also you can remove the rho and you will get these things. So this will be your answer. The value of Vx will be equals to V naught plus 4Q naught divided by 3 d into xq by L square d. Yeah, so I think from here your option D will be your correct answer, right? But this is very fundamental question. This is how you have to understand these things. If you have understood these things, then definitely this is going to be very easy question for you. But again, this was a classical question, how to apply this kind of balance. So in GATE examination, you have to critically think this kind of concept if it is coming in the paper, right? Okay. Now I will be moving towards the next question. The next question says that a siphon tube having a diameter of 2 cm draws water from a large reservoir. You can see in the image from the open reservoir and discharge into open atmosphere as shown in the figure. Assume incompressible fluid and neglected friction loss. The velocity at the discharge point is. You are supposed to calculate here velocity, right? So let's say if I am assuming this one is my point 1 and this one is the point 2, and if I apply the Bernoulli's equation, so I can write P1 divided by rho g plus B1 square divided by 2g plus Z1, that is equals to P2 divided by rho g plus V2 square divided by 2g plus Z2. So V1 square by 2g, V1 will be 0 here at this point, and both of 1 and 2 point is in open atmosphere. So P1 and P2 will be atmospheric pressure, so that will be getting cancelled throughout. So now I can say that Z1 minus Z2 that is equals to V2 square divided by 2g, and what is V2? V2 will be equals to root over 2g and obviously Z1 minus Z2, right? So the value of V2 will be equals to root over 2 multiplied with 9.8, and Z1 minus Z2 is total here 5, right? So root over 98. So you can calculate these things. What is the root over of 98? This is very simple, and I think you will be getting 9.89. So approximately 9.9 meter per second. So option A will be your correct answer. Now you are supposed to calculate what is the volumetric flow rate of water at this discharge point. So what is volumetric flow rate? Q equals to area multiplied with velocity. And what is the diameter of the pipe? That 2 centimeter, right? So you can calculate pi by 4 into 0.02 whole square into 9.9. So if you will calculate these things, then you will be getting so 0.03. So you are supposed to calculate in these things liter. So 3.11. So that will be equals to 3.11 liter per second. So from here option A will be your correct answer. Okay. After that, I'll be moving to ask the next question. Again, this question is very similar to the first question that we have done in this lecture only. So here you can see that a free jet of water is emerging from a nozzle having nozzle diameter here is given to you. So this is nozzle and having diameter here is your 0.075 meter, and this pipe diameter is given to you 0.225 meter. The velocity of water at point A. So here at point A, velocity of water is already given to you at this time 18 meter per second. And earlier question you are supposed to calculate these things. Density in the velocity of water at the tip of the nozzle. So it's very simple now. So if I apply, let's say this one is point C. So if I apply the Bernoulli's equation here, PA by rho g plus BA square divided by 2g plus ZA, that will be equals to PB by rho g plus BB square by 2g plus ZC. Is that clear? So PA and PB both will be, sorry, PC, it should be PC. I'm really sorry for that. It should be PC, VC square. So PC and PA by rho g, it will get cancelled because both of these ends are on the open atmosphere. And BA is given to you here at this point 18 square divided by 2 multiplied with 9.81 plus ZA minus ZC. So ZA is 18 and ZC is 0.5. So ZA minus ZC is equals to 21, I think. Yeah, 21. And that is equals to VC square by 2g, right? So once you'll calculate these things, let's try to calculate 2 multiplied with 9.81. So if you'll calculate this velocity, finally velocity you will be getting here 27.11 meter per second. Okay, from here option D will be correct. So this is very simple question. So only 2 steps you are able to solve this question and you will be getting 2 marks. Now what is the gauge pressure at point P? So now you are supposed to calculate the gauge pressure at point P, right? So now we can use the point B. So you can use the Bernoulli's equation at point B and point C, right? So again you have to calculate the velocity at point B. So velocity will be equals to how much? You can write area at point P multiplied with velocity at point B equals to area at point C multiplied with velocity at point C. So velocity at point B will be equals to dc square divided by db square multiplied with vc. So v will equals to dc. Diameter at point C is 0.075 divided by 0.225 whole square multiplied with 27.11. So let's try to calculate these things, how much we are getting. 0.075 divided by 0.225 whole square. So you are getting velocity at point P is equals to 3.0128 meter per second. Okay, now we have to calculate this gauge pressure at point B. So I can write PB by rho z plus BB square by 2z plus ZB, that is equals to PC by rho z plus VC square by 2z plus ZC. So ZC minus ZB is 0.5, right? So I can write PB divided by rho z, that is equals to PC. So PC here is open atmosphere. I can write 101.1325 Pascal divided by 1000 multiplied with 9.8 plus VC square minus BB square. So now I can write 2711 whole square minus 3.012 square divided by 2 into 9.8 plus ZC minus ZB will be equals to your 0.5. So now you have to calculate these things. So let's try to calculate 27.11 square minus 3.012 square divided by multiplied with 9.8 plus 0.5, 37.5 again plus, you can see here 101.325 divided by 9.8, right? This one multiplied with again 1000 multiplied with 9.8. So here you will be getting so you are supposed to calculate in kilopascal divided by 1000 minus 100. So okay, so finally here you will be getting, you are supposed to calculate the gauge pressure, right? So once you will get PB from here, so gauge pressure will be equals to, this is the absolute pressure and then I'll calculate the gauge pressure PB, that is equals to absolute pressure PB minus P atmospheric. So here you are getting 467 point something minus 100 kilopascal. So you will be getting 367 kilopascal, something like that. So option D will be your correct answer. So you have to understand what is P gauge pressure here. P gauge is equals to P absolute minus P atmospheric. So if P absolute you are putting in kilopascal, then you have to substitute atmospheric pressure also in kilopascal. Whatever the unit you are selecting, you should be consistent with the unit, right? Moving towards the next question, the question says that a Newtonian fluid of viscosity mu flows between two parallel plates due to the motion of the bottom plate, which is moved with the velocity v. So this bottom plate is moving with the velocity v here, you can see. The top plate is stationary, here velocity is 0, the steady state laminar velocity profile. So if we apply the Bernoulli, these things, Navier-Stokes equation, so momentum balance G minus del P plus mu del 2u by del y square equals to 0. So if I am neglecting pressure and gravity, so directly you will left with del 2u by del y square equals to 0. So you can say del u by del y equals to c1 and uy equals to obviously c1y plus c2. Is that clear? So this is the velocity profile. Now you have to substitute the boundary condition. When y equals to 0, velocity is equals to capital V. So v will be equals to c2. C2 you have calculated, and y equals to b, velocity will be equals to 0, means u will be equals to 0. So 0 equals to c1 into b plus c2. So what is b, c1? C1 equals to minus b divided by b. Once you get these things, then you can calculate velocity, that velocity profile uy equals to c1. C1 is minus b divided by b into y plus c2 is v. So velocity profile can be written as v into 1 minus y divided by b. So you can select which of the following options is correct. Option is correct. So from here, option D will be your correct answer. Is that clear? Okay, so after that I'll be moving towards the next question. The next question says the force per unit area that must be exerted on the bottom plate to maintain the flow is. So what is force per unit area? That is pressure. So obviously that is tau. That is obviously force per unit area on the bottom plate. So that is the shear stress there. Tau, that is equals to mu del u by del y at the bottom plate. So tau, that is equals to mu, and what is del u by del y? So del u by del y is equals to minus v divided by b from there. So I can write minus v divided by b. So the force per unit area is equals to minus mu v divided by b. So from here, your option B will be your correct answer. Okay. Now the mass balance equation for fluid with constant density and velocity. So del rho by del t plus del dot rho v equals to 0, means you are supposed to calculate the continuity equation. So option A will be your correct answer. So continuity equation in vector form can be written as del rho by del t plus del dot rho into v vector will be equals to 0. That is the continuity equation at unsteady state condition when varying density. And this is a general continuity equation, you can say. Now moving to the next question. This is also very good question. The question says that the initial water level in the tank is 4 meters. So let's say you have a tank, something like that. Okay. So initial water level in this tank, if I am assuming, is your 4 meter, and when a valve is located at the bottom, so here there is a valve which is located here. The rate of change of water level with respect to time, that is given, that is dl divided by dt, which is equals to minus k root t, and where the value of k is given to you 0.6. The level of water in the tank at a time t equals to 0.5 second. What will be the level? L is equals to what? Okay, so this is very simple question. So first you have to understand what is the velocity at this particular point. So velocity here is equals to root over 2z, and height is L. Is that clear? Because height is also changing with time. Okay. Okay, so you don't have to do anything, just already a correlation is given to you, that is you have to use this correlation dl by dt is given to you minus k root t. So I can write dl is equals to minus k root t dt, and I can integrate at time t equals to 0. Height was 4 meter, and what is time? Time is your 0.5. What is L? That's it. So what L minus 4, that is equals to minus k into t to the power 3 by 2 into obviously 2 by 3 multiplied with yeah, that's it. That is the integration. So L minus 4, that is equals to minus k into t. T is 0.5 whole to the power 3 by 2 into 2 by 3. So what is L? L is equals to 4 minus k value is given 0.6 into obviously 0.5 whole to the power 3 by 2 into 2 by 3. So let's try to do the calculation. This is very important. So the most important part of this particular problem is calculation, and to understand how you can use this differential equation. So finally you will be getting L height after 0.5 second is 3.85 meters, something like that. Is that clear? So the correlation was given to you, and this is just a simple ordinary differential equation you are supposed to calculate. That's it. After that, I'll be moving towards the next question. This question is also very important. This is based on the force balance and momentum balance equation. So a horizontal cylindrical water jet of a diameter d1 is given to you in the figure you can see, and the diameter d2, which is a hole there through which water is flowing. A part of this jet passes through the hole and the rest is deflected along the plate. So you can see here it is getting deflected along the plate along this direction and along this direction. The density of water is this one. The speed of the jet is 20 meter per second. Obviously it is given to you. The magnitude of the horizontal force required to hold the plate stationary is okay. So you can see that some force must be applied over here in order to hold the plate or in vertical direction, right? And some of these is passing through along this direction. So how much force is being applied from this direction? How can we calculate? So the force which is being applied due to this fluid on this plate, exactly same amount of force you have to apply opposite direction from this side. So that is F. So how can I calculate F? F can be written as rho, obviously rho A1 B1 square minus rho A2 V2 square, right? So if this part would not be there, directly we have calculated rho A1 B1 square, but due to this part, some part of fluid is getting leaked. That's why mass momentum in minus momentum out, that will be rate of change of momentum, that will give you that total applied force. So momentum in minus momentum out, right? That you have to use here. So F is equals to rho is constant and area is given at this point, that is pi by 4 into 0.02 whole square, and velocity is also given 20 square minus area pi by 4 into d2 is 0.01 whole square into obviously this velocity is 20 square. So velocity is same, only area is going to get changed. So that is 1000 density, and I can write pi by 4 into 20 square multiplied with 0.02 whole square minus 0.01 whole square. So once you do the calculation here, this is very simple calculation. Okay, so once you do the calculation, you will be getting 94 Newton approximately force that you have to apply in order to maintain these things. Yeah, 94.27 something like that. So that force that is being applied from the opposite direction in order to hold the plate on the at a stationary condition. Okay, I hope this question is clear to all of you. Now I'll be moving towards the next question, and I think this is the last question of the fluid dynamics. And here you can see that a cylindrical tank with a diameter is this one given to you, and a 5 millimeter diameter round on nozzle hole. Here you can see this hole is there through which fluid is coming. and the pressure above the water level in the tank maintained at 2 bar. So here you can see at this point pressure is 2 bar, and neglect the friction loss and entry loss. Use acceleration due to gravity. This one, the absolute value of initial dh by dt. So you are supposed to calculate dh by dt at t equals to 0 will be what if total height of the tank is given to you, that is your 51 centimeter, which is 0.51 meter. Okay, so in order to calculate these things we have to calculate first, yeah, so at t equals to 0 the total height will be h. So if I apply continuity equation, so I can write a dh by dt, that is equals to at this point, that is total discharge will be how much, area into velocity. So area at this point, let's say at this point this one is 0.1 and this one is 0.2, so this one is a1 and this one is a2 and velocity v2. So what is dh by dt? Dh by dt is equals to a2 divided by a1, and v2 will be equals to root 2 zh. At t equals to 0 height will be h, right? So that's why we are calculating this thing, dh by dt. And what is a2? A2 is pi by 4 into 0.5005 whole square. So I'll write 0.005 whole square divided by a1. Area is your 0.5 whole square multiplied with root 2 gh. 2 into z is 10, and height, initial height is given is 51 centimeters, so 0.51. So let's try to calculate this one. So 0.51 multiplied with 20 whole over root multiplied with 0.005 whole square and divided by 0.5 whole square, this one, and you are supposed to calculate in millimeters, so multiplied with 1000. So basically from here you will be getting the value 1.45 millimeter per second. Okay, that's all. So in the next lecture I'll be talking about flow through pipe. So hopefully within 1 to 2 days I'll be able to complete the whole PYQ of fluid mechanics, and after that you will be feeling good confidence in your fluid mechanics topic, especially for the GATE examination, right? And this will be very much helpful for Coal India exam and also for BARC exam. Okay, thank you all.